Hello everyone, welcome back to MATLAB programming course. Today we're going to learn more about the functions and their effect on matrices. Let's start by creating matrix. We do have matrix A. Yes, okay. So we have created matrix A here, and what I want to do is to find sine of A. And if you do that, you will notice again sine, as we learned earlier, whatever comes inside the parentheses is going to be in radians. So MATLAB always performs in radians. This is 1 radian, 4 radian, and stuff like that. Therefore, MATLAB calculates it easily. We can do another hyperbolic function and get the same result. We can come up with matrix B. So it's B. B is like that. So let's do cosine of B, see what happens. You see that MATLAB has no problem calculating that. Another function that we frequently encounter in matrices is square root. So as we learned, we can calculate the square root of A, and let me bring A here as well. So square root of 1 is 1, square root of 4 is 2, and square root of 6 is 2.4, and so on and so forth. However, in MATLAB there is another function, square root, which is specifically designed for matrices. In order to do that, you can type duck sqrtm. So instead of sqrt, now we do have a sqrtm. And if you do that, it's a matrix. M stands for matrices. So if I do that, you can see that there is a definition. Sqrt of A is the principal square root of a matrix. X by X equals A. So I wanted to know what are two other matrices that if I multiply them together, I can find the matrix A. So let's try that. If I say sqrtm of A, I get matrix which is complex now. And let me name a value for it. I name it R. sqrt of A, sqrt of M. Now I do have matrix A, which is the square root of A. Now what happens if I multiply R with itself? You know, it's a square root of matrix A. Therefore, if I multiply it once more with itself, it should create the original matrix A, and it does. If you look closely, you see that they're imaginary numbers, but they're all 0, right? So we came up with the same original matrix A. If I type matrix A here once more, you can see that now they're identical. As we learn, 2 multiplied by 2 equals 4. And this one, the same, is true with sqrtm of A. So how MATLAB interprets this function is that what are those two separate matrices that if we multiply them together, it's going to create matrix A. And this is the result. Let's do it with B as well. So what is B? sqrtm of B, and you see that there is an error which indicates we're only able to perform such action on squared matrices. So if you ever wanted to use the sqrtm of A or any other matrix, please make sure that your matrix is a square one, else there's going to be an error. This is not as common as sqrt of the matrix, but there are special applications where we need to do that. Those studying in control engineering field frequently use this function. Let me clear the screen. So I do have matrix A, and we do have the same concept with exponentiation. So if I put exp of matrix A, and MATLAB just easily calculates the result. However, there is another function in MATLAB which is specifically designed for dealing with matrices when going to and the function is exp of matrix A. Now if I do that, you see that a new result will appear. And just to give you a short introduction with this one, this is also known as phi matrix, and it is very fundamental in probability, in control engineering, and we can easily find the response of a system, including the transient and the steady state responses, by calculating only this function. So it is really important. It has a special use, but there are times you need to use the exponential function for matrices. The same is also true with logarithmic functions. So if I put logarithmic A, it just goes and calculates the logarithm of each element. Let me clear a screen and put A here, and then log of A is going to be calculated one by one correspondingly and put it here. But there is also another function called log m of A, and if we calculate that, there's a warning, just ignore that, but you see that a new entity is just created, which is totally different from what we got here. And I wanted to emphasize that the whole story here is that if you're dealing with matrices, so there are special functions for them designed in MATLAB, and be aware that if you calculate the normal functions, they're going to produce different results than those functions specifically designed for dealing matrices. It is a very important point to remember. Let me clear a screen for the last item here. What if we wanted to raise the matrix, raise a number to a matrix, like 2 to power A? We do have a matrix, we do have a number, and we want to raise it to a matrix. So if we do that, MATLAB easily calculates the result. These functions have special usage, and be sure that you're mindful of that. Be sure that you know where to use them. For example, if you wanted to do it element by element, which is more frequently used, we can put it like that, as we learned with dot. It indicates that each element inside A is going to be raised. Please note that we do have a different notation when we raise the matrix to a power, like this one. So let me clear the screen. This is A, and what if I wanted to raise the matrix to power 2? So if I do that, you see that a new result, which is also a matrix, is created. But the answer is not really relevant. It doesn't make sense that 1 to power 2 is going to be 27. Again, remember that we do have element by element multiplication, division, subtraction, and power. So if I do that, now you see that 1 to power 1, 1 to power 2 is 1, 4 to power 2 is 16, 6 to power 2 is 36, and so on and so forth. The beauty is that whatever we learned so far is applicable to newer functions, to newer matrices, algebraic functions, and whatever we learn, it is just interconnected together. We need to practice using them together so we feel confident while we're dealing with programming. Thank you very much for watching this, and I'll see you in next video.